Assalamu alaikum grade 10 students. We are going to explain the part 1 of chapter 4, which is about vector coordinates. Objectives: identify the reference of a line and its notation. Identify the abscissa of the midpoint of a segment in a reference. Calculate the algebraic measure of a vector. And finally, recognize Ch4's relation for algebraic measures. Materials: textbook, pens, draft papers, copybook, and calculator. Reference of a line. Definition 1. Let D be any line and let O be a point on D. We call a reference of line D the couple OU, where the point O is called origin and U is the direction vector of D. Remember that a direction vector of a line is any vector having same direction with this line. Notation 1. We use the notation OU to represent a reference of a line. So this is the notation of a reference. A remark: a line D with a reference OU is also called an axis. Abscissa of a point in a reference. Definition 2. Let OU be a reference of line D. Let M be a variable point on D. The two vectors U and OM are collinear. As you see here, U and OM are collinear, so there exists one and only one real non-zero number K such that OM equal KU. OM equal KU. This is agreed upon. K is called the abscissa of M and is denoted by XM. If U and OM have same sense, then K is positive, while if they have opposite sense, then K is negative. If K is the abscissa of M, so OM equal KU, and we can also write M of K. This is another notation for abscissa. Example 1. OM equal 2U, then the abscissa of M is 2. We write XM equal 2. If OM equal minus 8U, then the abscissa of M is minus 8. We write XM equal minus 8. OO equals 0, then the abscissa of O is 0. XO equal 0. Conversely, if M of 6, if the abscissa of M is 6, then XM equal 6. Note that the abscissa of the origin is always equal to 0. Application 1. Please stop the video a few minutes to solve. OA vector equal to U vector, so XA equal 2, we write A of 2. OB vector equal minus U vector equal minus 1U, since OB and U having opposite sense, so we write B of minus 1. The abscissa of B is minus 1. OC vector equal plus 4U, so XC equal 4. OD vector equal 3.5U, so the abscissa of D is 3.5. Abscissa of the midpoint of a segment. Definition 3. Let OU be a reference of line D. Consider the 2 points A and B on D and let I be the midpoint of AB. The abscissa of I in this reference is XI equal XA plus XB over 2. This is the formula of the midpoint of segment AB. Example 2. In the reference OU of line D, given the points A and B of respective abscissas minus 4 and 2, find the abscissa of I, the midpoint of AB. Solution: by applying the formula XI equal XA plus XB over 2 equal minus 4 plus 2 over 2 equal minus 1. Application 2. Please stop the video a few minutes. Part 1. See the figure. The abscissa of A is minus 1 and the abscissa of B is plus 5. Find the abscissa of I, the midpoint of AB, by applying the formula XI equal XA plus XB over 2 equal minus 1 plus 5 over 2 equal 2. So I having abscissa equal 2. 3. Let J be the symmetric of I with respect to O. Here O is the midpoint of IJ. So 0 equal 2 plus xj over 2. Cross multiplication, we get that xj equal minus 2. Algebraic measure of a vector. Definition 4. Consider the reference OU of line D. Let A and B be 2 points on D. The two vectors U and A, B are collinear, so there exists one and only one real number k such that A, B equal KU, k different from 0. K is called the algebraic measure of vector AB. The algebraic measure of vector AB is denoted by AB bar. This is the notation of algebraic measure of vector AB. So we have AB vector equal AB bar times U vector. OA vector equal OA bar times U vector, and OA vector is also equal XA times U vector. So by comparison we get that OA bar equal XA. So the abscissa of A represents the algebraic measure of vector OA. Example 3. If AB vector equal 3U vector, then AB bar equal 3. And if AB vector equal minus 8U vector, so AB bar equal minus 8. Application 3. Please stop the video a few minutes to solve. In part 1, we have AB vector equal 2U, then AB bar equal 2. The algebraic measure of vector AB is 2. Same for vector AC. AC equal minus 4U because AC and U having opposite sense. So AC bar equal minus 4. BC vector equal minus 6U. So BC bar equal minus 6. Part 2, place the point D such that AD bar equal minus 3. AD bar equal minus 3, so we can say that AD vector equal minus 3U. From A to D we have 3 units to the left, in a way that AD vector and U vector having opposite sense. 1, 2, 3. So D here is in this position. Chase this relation for algebraic measures. Definition 5. Consider the reference OU of line D. Let A and B be 2 points on D and M be a variable point on D. We have AB vector. If we introduce a letter M here, so AB vector equal AM plus MB, we get that AB bar times U equal AM bar times U vector plus MB bar times U vector, which is proved before. And if we take a common vector U here, we get AB bar times U equal AM bar plus MB bar times U vector. And since U vector is a non-zero vector, so we get that AB bar equal AM bar plus MB bar if we simplify U here and there. Remark: AB bar equal AO bar plus OB bar, but AO bar equal minus OA bar, so AB bar equal OB bar minus OA bar, hence AB bar equal XB minus XA. BA bar equal XA minus XB, so AB bar equal minus BA bar. Example 4. In reference OU given the points A and B of abscissas minus 1 and 5 respectively, calculate the algebraic measure of vector AB. By applying this formula, we have AB bar equal XB minus XA equal 5 minus minus 1 equal 6. Algebraic measure of a vector. Application 4. Please stop the video a few minutes to solve. IJ bar equal XJ minus XI. We apply the formula of the midpoint here and here. So IJ bar equal XJ minus XI, which is equal to minus 3 minus 2 minus minus 3 equal 1. Part 2, algebraic measure of vector AB. AB bar equal XB minus XA equal minus 8 minus 2 equal minus 10. Part 3, calculate the algebraic measure of vector BD such that AD bar equal minus 3. Here BD bar equal BA bar plus AD bar. so it's equal to 10 minus 3 equals 7. Then deduce the abscissa of D. Since BD bar equal XD minus XB equals 7, and we have XB equal minus 8, so minus XB equal plus 8, so XD equals 7 minus 8 equal minus 1. So the abscissa of D is minus 1. Summary for this part. Coming next, please study well and good work.